So, naming acids. We're talking about acids. We've already kind of went through this. HCl, it's a molecule. It's called hydrogen monochloride. And there's the Lewis dot structure. Okay? Now, a funny thing about acids is there are molecules. They are molecular. But, yeah, all acids are molecular. It is made out of hydrogen, which is a nonmetal, and chlorine, which is a nonmetal. So it's molecular. And these are, in fact, molecules. This is a gas. Hydrogen monochloride is a gas that floats around in the room. Highly poisonous. You won't want to breathe this gas. Okay? But if you take this molecule and you mix it with water, so here's the substance in a beaker. Add water to it. A funny thing happens. This is actually a chemical reaction where it breaks the molecule into two pieces. And those pieces have charges, which makes them ions. One of the pieces is hydrogen with a +1 charge. The other piece in this case is going to be chlorine with a -1 charge. Okay, on your note packet, I think I wrote carbon instead of chlorine, so you can put a little L there. But it's got a -1 charge. Hydrogen's got a +1 charge. Now, all of the acids are going to be molecules that involve hydrogen. So one of the ions is always going to be hydrogen with a +1 charge. This process is called ionization. So you add water to this molecular compound, it ionizes and it breaks apart into two different ions. Now this is different from other ionic things, because other ionic things are positive and negatives that stick together in a repeating pattern. This compound is only going to be ions when it's mixed with water, and if they ever come back together again, it's not going to be ionic anymore, it's going to be a molecule again. Does that make sense? So this is kind of like a weird molecule that turns into ions, and then when it comes together again, it turns back into molecules. So it kind of goes back and forth depending on if they're together or they're apart. And water, although it's involved, is not actually involved. All water is doing is breaking it into pieces and keeping them apart. So these things are floating around in the water as ions, charged little particles, and those charged little particles do things. Some of that stuff can be dangerous. Some of that stuff can be quite helpful. All right? There's lots of acids in the world. Some of them are highly dangerous. And some of them are not dangerous at all, and you actually need them to live. For example, the one we have right here is called hydrochloric acid, HCl. That's your stomach acid. Without stomach acid, you couldn't digest food. Should you drink hydrochloric acid? No, that probably wouldn't be a good idea. It wouldn't kill you, though, because basically it's like reverse vomiting. Like, it'd be the same sensation as throwing up, except in reverse. Because you're swallowing your stomach acid instead of having it come out. Yeah, so not really a great idea to drink it, but is it going to kill you? No. It's going to make your throat hurt really bad, though. Okay?
That just makes me want to.
There are some acids, though, you should not drink. Sulfuric acid is highly poisonous. Don't drink that. That's actually battery acid. Phosphoric acid is not very poisonous. You actually have a lot of it in soda. Don't drink a ton of soda, but phosphoric acid's okay. It's an ingredient in soda. Which one? Sulfuric acid's poisonous. You can touch sulfuric acid with your skin. It's not going to harm your skin, but it will harm most of your organs. Yeah. Yes, Sam. Okay. Now, there are a couple of acids that will actually do serious harm to your skin. I'm not going to let you guys touch those. Those include hydrofluoric acid, nitric acid. Like if you get those on your skin, it will start like eating your skin. So we're not going to be touching those. All right, I'm not going to ever hand you one of those. But the ones that I am going to hand you, they'll be nasty to your intern sometimes, like internal organs, but they'll be fine if you spill them on your skin. Okay? Now, acids, because they are molecules, but they're also ions, they have a different naming scheme. Okay? There are actually two kinds of acids, binary acids and oxyacids. So I want to start with the binaries. So these are three binary acids. A binary acid is hydrogen and some sort of non-metal element, okay, which has a negative charge when it's in the water. So they're anions. Anions are negatively charged things. So we've got the chlorine one with hydrogen. We've got phosphorus with hydrogen, and we've got bromine with hydrogen. Okay? The chlorine one is called hydrochloric acid. The phosphorus is hydrophosphoric acid. And the bromine one is hydrobromic acid. Do you guys see a pattern here? First off, they all start with hydro, right? Hydro indicates it's a binary acid. If it doesn't have hydro, then it's not a binary acid. We're going to get to the other kind in a minute, but hydro is for binary acids. I've also included the name of the element that we're pairing it with. So chlorine, chloric. Phosphorus, phosphoric. Bromine, bromic. We are changing the ending to what? Ic. Ic. And then we're adding the word acid. Okay? So here is something for you to write down. Binary acids. That means hydrogen and another element. So there's two things there. Hydrogen and another element, and it's going to be a nonmetal. To name it, use the prefix hydro. Start with that. That means binary. Use the anion, which is basically what element you're dealing with. Chlorine, phosphorus, bromine. Then you're going to change the ending of that to ic, and then you're going to tack on the word acid. All right, so a couple of examples. First one, HF. That's the formula of the molecule. That is an acid. What would we call it? That would be called hydrofluoric acid. Hydrofluoric acid. We add hydro, it's fluorine, change the ending to ic, add the word acid. Hydrofluoric acid. Now, for this next one, hydrosulfuric acid, what would the formula be? It is hydrogen and sulfur. But what is the charge on sulfur? -2. Since this is kind of partially ionic, you can use these to figure out the formula. It's a -2 charge, and hydrogen's a +1 charge. So the formula is not just HS, it's H2S. 2 hydrogens are going to be attracted to that -2 charge of the sulfur. Right? Since this is ionic and molecular, depending on if it's in water. You can use the charges to figure out the formula, just like we were doing with ions. So these are binary. Binary acids. Hydrogen and another element. There's two things there. The other kind of acid is called oxyacid. Oxyacids have oxyanions, which are one of the polyatomic ions that we talked about when we were talking about ions. All of the oxyacids are the ones with oxygen in them. That's where the oxy comes from. So we're dealing with polyatomic ions that deal with oxygen. So to tell you have an oxyacid, you're going to have hydrogen still, because it's an acid. You're going to have oxygen in there, and then you're also going to have some other elements. So there's going to be at least 3 elements. One of them will be hydrogen, and one of them will be oxygen. Okay? So naming these. HClO3, well, that is a chlorate. That's the polyatomic ion that's attached to the hydrogen. We call it chloric acid. Versus HClO2, that's chlorite. We call that chlorous acid. So chloric acid, chlorous acid. Sulfate with hydrogen, H2SO4. We call it sulfuric acid. And sulfite, SO3 with a -2 charge, H2SO3. We call that sulfurous acid. So there's a pattern here as well. The acid's either ending in ic or os. Which ones end in ic? The one with more oxygen, which end in 8. So if it ends in 8, the ending changes to ic. If it ends in ite, the ending changes to os. All right? So naming these guys. We have hydrogen plus one of the polyatomic ions, the oxyanions. The root word of the anion, whatever anion it is going to be used for the name of the acid. The ending is changed either to ic or ite. Or excuse me, ic or os. Ate changes to ic. Ite changes to os. And then you add the word acid at the end. It's almost a tongue twister. Ate changes to ic. Ite changes to os. Ate to ic, ite to os. Ate to ic, ite to os. Now I want you guys to add off to the side a fourth little thing here, and that is what not to do. So write this down. Do not add hydro. None of those names had hydro in them, but the binaries are the ones with hydro, okay? So it's not something you should do, which is why it's not part of this description here, but it is a common mistake that you think you should add hydro to everything because it's got hydrogen in it. You don't. Hydro means binary, right? So add that as a little note. Do not add hydro to the name. Something you're not supposed to do, so. So, let's try a couple of examples. HNO3. This is an oxyacid, hydrogen, and a negative oxyion. So, look at your polyatomic ion sheet. What are we talking about here? Which polyatomic ion? Which oxyanion? So NO3 is nitrate. You guys find it? Nitrate. So if it's 8, what do we change the ending to? Ic. So it's called nitric acid. Nitric acid. Going backwards, chlorous acid. Chlorous acid. It ends in us. So what are we looking for? Which polyatomic ion? Ite. Us means we're looking for an ite. So we're looking for chlorite. Okay? Chlorite, ClO2 with a -1 charge. So what would the formula be? It's got a -1 charge. Hydrogen's got a +1 charge. So what's the formula? HClO2. Now, another little addendum here. Let me grab my little writing utensil. Okay. I want to highlight that we're writing the hydrogen first. You guys see that? Just like when we write a positive ion, we write it first. So we write the hydrogen first in this formula, we write the hydrogen first in that formula. I'm pointing this out because there are lots and lots of molecules that have hydrogen in them. And some of them are acids and some of them are not. So CH4 is not an acid. NH3 is not an acid. But H2S is an acid. You guys see the difference here? Molecules which hydrogen is written first are acids. And then molecules which hydrogen is not written first, it's either last or it's somewhere in the middle or something like that, those are not acids.
Gotcha.
Okay? So we do have some molecules that have hydrogen, but they're not acids. And we have some that do have hydrogen, and they are. And to distinguish them, acids, we write the hydrogen first. And if they're not acids, we don't. We include the hydrogen, make sure it's one of the later ones. Right? We also have some where some hydrogens are acidic and then others are not. Like this one, HC2, H3, O2. This one, we have one hydrogen that is acidic, and the other three are actually part of that polyatomic molecule, polyatomic ion, and they're not going to break apart, so we keep them separate. Okay? Really, this is H4. Do you guys see that? 4 hydrogens. But we write the one hydrogen separate because one of them will break apart and the other 3 will not. Okay? Questions?